Okay, my friends, everybody's worried about corona, and we're going to look into it, what it does to your lungs, and what you can do to help to protect yourself. Because there are little things you can do. Breathing exercises, I believe, can alleviate some of the situation. I'll tell you why I think that. This is a lung. All right, this is one of my fossil lungs. You see those little holes, those little round circles all over the place? Those are the same as these. All right, they call them alveoli. Well, I was always told in my courses that they were round balls that looked like that. Well, I don't believe that whatsoever, no. I believe they are flat little flaps like this. All right, the air comes in, and these are only like this far apart. I mean, they're just as close as they can get, and still have the gases flow through here, because you're bringing oxygen in and you're taking carbon dioxide out. And that's another very interesting thing. You know, we're bringing oxygen in. How's that oxygen going back out again? You got carbon dioxide. So you're sending out oxygen again. You were bringing it in, sending it out. What's that all about? Where does the carbon come from? And what's the carbon? Why is the carbon attached to the oxygen when it leaves? A lot of things to talk about here. And what about in your body? Do you have any free carbon in your body? What about activated charcoal, which is nothing more than carbon that's been, every last bit of it's been driven off, so you have extremely active carbon. The sites on it want to bind with things and bond. That they put that stuff into people to pull poisons out of them. Maybe you're overloaded with the dioxides, and you need the carbon in there to pull those out. I don't know. There's a lot of stuff that can be looked at here. But this is what your lung looks like in here. So we know we're starting out with this. We're not starting out with big balls. So as they collapse, you lose it. You're done. All right? And if they fill up with fluids, you're done again. So what do you have to do? Deep breathing exercises, I think, would bring them up like this a little bit, a couple times. And then I've always been able to cough up some stuff after doing, a few, a minute or so of deep breathing. You don't have to do a lot of it. But I don't see any reason that shouldn't be a regular daily practice, deep breathing. And I see people are doing that now. And I support that. I see that as lung health. It's expanding, expanding, expanding. You want them to stay open as much as you can. The more open these are, and the more available these molecules, because they're nothing more than certain molecules. They're biological, but they're still molecules that want to attach to something else. That's the nature of a molecule. It's either stable and it doesn't want to do anything with anybody, or it's in a degree of reactiveness. Some of them are extremely reactive, combustive, and some of them sort of try to find a way of attaching. It's a symphony. I keep referring to it as a symphony. There's a million pieces in it, and every little piece has to know exactly the right notes at exactly the right time. Okay, my friends, as I always do with everything, I never accept anything from anybody. I don't care what the source is, unless they can back it up with support. So, what is support? Support isn't, I can take this one little thing and support that. No, you have to start from what is respiration. If I'm going to be talking about your lungs, I should know what a respiration is. So I started at the beginning. What is respiration? Well, guess what? When you breathe, all of the stuff that goes in your lungs, you have to maintain a residue. You see this? It comes down to here. You only breathe in 350 milliliters per breath, let's say, and that's 1/3 of a liter, and you have 2.5 liters in your lung. So you're just supplementing your lung, and that gives it what they call a functional residue. And that residue is totally different than the outside air. The gaseous composition, totally different than the ambient air, which is the air outside that you're breathing. And there's a difference between, when you breathe in, there's all kinds of different things that are going on in your lung, the transfer of these molecules. It's not really that complicated, but there's a organic molecular component to it, and then there's a mechanical component to it. And I focus on both of them. And the mechanical component is what I think we can do something about. And also we can do something about the molecular, if whatever you take into your body is this. And some people eat a bunch of this, some people eat a bunch of this. This is going to get sick, these guys won't. It's basically that simple. And glyphosate is one of the major disasters in our entire world right now because it mimics the GLY type molecules in your body that are the absolute essential molecules for life. Now, how they react, I can't say exactly, but I can tell you what, there's a lot of disease, there's a lot of sickness, there's a lot of autism, there's a lot of neuromuscular problems and Alzheimer's, and I mean every single thing that you would expect a healthy person not to have. And they're coming on earlier and earlier, and a lot more autism, and we've been able to really reverse autism by putting the right kind of bacteria in the gut. I'm telling you, it's, as a matter of fact, I should show you the email. I'm going to show you the stuff from Facebook, because I can prove it. Okay, my friends, as I said, or maybe I didn't say it, but I'm going to say it now, I haven't seen a lot of real serious research on how this coronavirus actually reacts in the body. Specifically. Now, this guy apparently has world-class instructors, and let's see what they have to say. It's 11 minutes long. I'm going to play it, and then we'll pull it apart.
Cram.com. Welcome to another Make Cram lecture. So I hear this question a lot. How does the coronavirus actually kill people? There's a recent article in The Lancet that showed that of 41 people that were admitted to the hospital, 6 of them died, and all of them were on ventilators, and they died with something called ARDS. And ARDS is how the coronavirus kills. It's not just the coronavirus, but many other viruses, including the influenza virus that we have every year. How is it that this happens? It's through acute respiratory distress syndrome, and I'm going to explain to you how that happens. So you first have to understand lung anatomy, and to understand that, I like to show you a tree. So a tree has a tree stump, and then it branches, and then those branches branch, and then further those branches branch, until finally you get to the leaves. And these leaves capture the sun's rays, and that's what gives you photosynthesis, and that's how the tree lives. And so what happens is that this tree and the branches increase the surface area of the leaves on the tree, so that if you were to pluck off all of the leaves and you were to put them on the ground next to each other, the surface area that is represented by those leaves would be larger than the shadow that is produced by the sun on that tree. Well, it's the same exact thing that happens with your lungs. You've got an airway, and then that airway divides into a right mainstem bronchus and into a left mainstem bronchus, and then you have a right upper lobe, you have a right middle lobe, right lower lobe, left upper lobe, and you have a left lower lobe. So this is the left side, this is the right, because you're looking at the patient. And then these things, of course, divide into much smaller branches. And instead of leaves at the end of all of these things, what you have is something called an alveoli, which is a tiny little small grape-like structure that the air gets into. And the air, of course, has oxygen. So what does this look like on a large scale? Here's what an alveolus looks like.
Here's what it looks like on a large scale. You see that? That's a Mudfossil lung. And that is those little alveoli that he talked about. You see those little circles there? All right, we go back to this.
How many alveoli are there in the human body? Well, there's about 600 million of them. These are very, very small. So what happens is
Well, you know, I don't think they're that small. I mean, there might be 600 million of them, but I'm going to tell you what. If that's what he's talking about right there, those things aren't that small, but this is a big, thick thing. And they come out and they end up at these little, I mean, this is exactly what it is. They look like little keyholes. They come out and then there's a little circle. It's identical to what he's showing here. Now, there might be 600 million of them in here, but I don't know. That seems like an awful lot, but I mean, you could see them. There's absolutely no question that they're here. And there's absolutely no question this is a lung. And it's the pleurer, which is the coating on the lung, is gone. Normally, you would have, and this is another Mudfossil lung. This one here, the pleurer is not gone. It's just like somebody cut it out of a person's body and dried it out. And see the flat plane on the back? This was all, they said there was a great flood. There damn sure was. And that's why these things are all flat like this. And I have them coming out of my earlobes.
Oxygenated blood comes by, and its job is to pick up the oxygen that comes in to the alveoli. And then when that oxygen comes in, it oxygenates the blood, and then that blood goes back to the heart and then to the body and all your muscles. That's how you get oxygen. And so you can imagine that this is very, very thin, because the oxygen which comes down here has to diffuse into the bloodstream. So far, so good. But what happens? Well, just like when you hit your finger in the door, your finger swells. That's because there's inflammation occurring where you hit your finger in the door. And inflammation causes a leakage of fluids into the tissue space. So what happens here is that you get a viral infection. The virus affects your lungs. And with ARDS, the entire lung becomes inflamed. Not just in one area like you would have with a pneumonia, or one particular area, for instance, on your finger, and it would just stay in one particular finger and your whole hand wouldn't swell. No, with ARDS, the entire lung goes crazy with inflammation. And so what happens here, instead of having a nice thin area, inflammation goes everywhere, and you get a large barrier of fluid that goes into the interstitial space. Furthermore, these capillaries start to become leaky, and fluid starts to leak into the alveolar space as well, and this starts to fill up with liquid, proteinaceous liquid, liquid that prevents oxygen from getting into the bloodstream. And so instead of having nice oxygenated blood, this blood becomes hypoxic, and you become hypoxic if you have ARDS, and you have a hard time breathing, and that's when you get placed on the ventilator. There's really nothing you can do to speed this up. There's nothing that you can do to slow it down. You have to be supported on the ventilator so that you're getting enough oxygen and that the machine can breathe for you until, just like everything else, after you hit your finger in the door and the swelling goes away, this fluid will eventually go away as well. The key, though, is keeping you supported during that period of time until the fluid goes away. And then, once again, the oxygen will be able to go back into the system, and you will get oxygen back to your tissues. So here's another look at that. We get oxygen that's going down into these terminal structures called the alveoli. They go into these alveoli, and they cause deoxygenated blood to turn into oxygenated blood and then go back to the heart. So I'm going to show you 3 things today that we have learned in the last 20 years that can improve survival in these patients who are on ventilators to help them beat coronavirus. Or, for that matter, any other virus, whether it be influenza, whether it be respiratory syncytial virus, any other kind of virus, for beating and getting better if you have ARDS and you're on the ventilator.
All right. Well, I'm totally interested in what he has to say, but I also can tell you this: if your body has the correct nutritional components inside of it, and the correct bacteria, and the correct, I'm going to call them viruses. They're enzymes, but they do exactly the same thing as viruses do. All right? They attack things and break things up. And that's, in my mind, that's what viruses do. Now, he's saying that they create a lot of inflammation. Yes, but they're attacking something, they're breaking something. Why are they getting inflamed? It's not just because they're there. They have to be affecting something. And in my world, when you affect something, you break it. You break it. And then when it breaks, it spews out a whole bunch of stuff that has to be dealt with. And it can't be dealt with because it's stuff that you weren't expecting. You weren't expecting it. This virus is something that is coming from somewhere else, and I think it's coming from Well, I don't know where it's coming from, but I don't think it's a normal, I don't think any of these viruses that attack people, with this kind of virulence are natural, because otherwise you'd never have any population. They'd be popping these out every year. Well, I think there's something else going on. I think it's got something to do with the way we're feeding the plants. And then we eat the plants, and now we got issues.
So the first thing that we're going to look at is what they noticed back in 2000 and actually before, is that when we put people on the ventilator and the ventilator puts a breath into their airways, what we were trying to do is we were trying to make sure that we were ventilating patients well. And that's important in some situations because the blood that is poor in oxygen also has carbon dioxide, which is given up from the muscles. Well, this carbon dioxide would need to be ventilated to be taken out on exhalation, so CO2 would be coming out. Well, in order to do that, we had to make sure that enough volume of air was going back and forth, back and forth.
You know what else you need is enough carbon in your body. C is carbon. All right, carboxylation. This is another thing that I've been working on, is carboxylation. And if you don't have enough carbon moving around through your body, you can't carboxylate these things. Now, I don't know if that's a valid argument or not, but I think it's something to think about.
The problem with that, though, is that we were inflating these alveoli, and then when we were releasing the pressure and letting the air out, these alveoli would collapse down, and nothing was keeping them open. So they would be opening and closing, opening.
You see, obviously this is not something to do with the chemistry. I don't know if it is or not, but this is a mechanical problem, and not just lacking carbon, but lack of carbon might cause this. It might try to be finding that carbon, squishing itself down. I don't know what it's doing, but I would make sure you have enough carbon in your body.
And closing, shutting and opening. And so that was causing a lot of shear stress. And of course, what's the whole problem here that we've got? Inflammation is what's causing the whole problem here in the first place. And that's causing these membranes to become very thick, and the oxygen can't get in there. And so by ventilating these patients with large tidal volumes, we were causing the inflammation to actually get worse than it would have been if we hadn't done that. And so the scientists started to look at this and say, wait a minute, what happens if we just put a lot of pressure down here to keep these alveoli open and only use a small amount of tidal volume to ventilate these patients? And yes, we won't be able to get as much carbon dioxide out of them, but we don't really care so long as we're not adding more inflammation to it. And so that first thing that we looked at, this is back in the early 2000s that this came out, is low tidal volume. And that would almost certainly cause the PCO2s, or the partial pressure of carbon dioxide in the blood, to go up. So this was called a low tidal volume strategy. And sure enough, a paper was published in 2000 in the New England Journal of Medicine that showed that we could affect change and we could decrease the mortality at the time from 40% down to about 31% mortality. So that was a huge drop in mortality. And all we did was we just ventilated people differently using low tidal volume. Now, when you're ventilating people with low tidal volume, it's not very comfortable. They're trying to breathe more because they don't like the increased carbon dioxide levels. And so they would try to breathe over the ventilator, and they would try to breathe differently than what the ventilator was telling them to do. And in these cases, we would usually sedate the patients, but if we sedated them too much, bad things could happen to them. They could get blood clots, their blood pressure would go down. And so the second thing that they came up with was actually paralyzing these patients using medications so that they were in perfect sync with the ventilators. And so that was paralysis. Paralysis requires pretty intensive care in the intensive care unit. You need good ancillary services. You need good respiratory therapists. You need good nursing. Something that you might not get if there's a huge outbreak, but you could get if attention was made to this. So this paper, also published in the New England Journal of Medicine, and by the way, I'm going to give links to all of these papers in the description below, they were able to drop the mortality from 41% down to 32%. And this paper was published in 2010. So far, so good. What we also started to realize is that patients in the hospital, for whatever particular reason, if you ever look at them in bed, they're on their back. And what we decided to do was flip them over. And there was a number of reasons for this, so that their belly was down and that their back was up. We call this prone positioning. And if you do this for about 17 to 18 hours a day, you can actually decrease the mortality they found from 33% down to 16%. And this paper was published back in 2013. And so you...
Now, why would that be? The only thing I can think of is you're putting more pressure on your chest, the collapsible part of your chest. Your back, laying on your back, nothing collapses. You can't. I don't think you can't feel the effect of the back pushing against your lungs. I think from the front, you're going to feel a compression of your lungs, and maybe it makes you breathe harder or something, and maybe that's what does it.
You can see here 3 breakthroughs in the treatment of ARDS, the final common pathway for morbidity and mortality in the coronavirus that we're talking about. But the other thing about this that's interesting is we can do a lot if we catch it early and we get people into the hospital and we get them in the intensive care unit and we get them on ventilators and we're able to appropriately treat them with good quality medical care. And 3 things that really make a difference, then we've got a good chance so that they're not another statistic of mortality, but they survive this. And so really the purpose of putting these updates on is to make sure that people understand the medical background of what's going on. Sometimes these stories about outbreaks can be very scary, and for good reason, but we need to understand medically what it is that's going on, because knowledge is power.
I agree 100%. We need to know everything about these things, but we also need to focus in very, very carefully on the nutrition side. And what, they've always, organic. Yes, absolutely. When you eat these things that they have engineered to go against nature, and that's what they did. I don't care what anybody says. They made Roundup, which is it kills anything, I guess, just about, except for the things that they remanufactured with what they call genetically modified things. Genetic modifications. Nobody, God is the one that modifies that stuff. This is insanity. This is what really upsets me. And I know I'm going to go off the rails again, but I can't help myself. And they, even when you present the evidence, all they do is cover their bases. They go, oh, no, there's too much money involved in this. They could make the stuff grow. You just have to use a little more manpower. And we got a lot of manpower laying around doing nothing as far as I could see. So I'd rather be healthy and put people to work than end up getting sick and letting people not work. I don't know, that's a stupid argument, but you know what I'm saying. It just, everything seems to be upsetting me lately, and I'm sorry for that. I love you. I really do. I love everybody. I just want to get past these nonsense things. All right? and get into understanding the reality of the divine. All right? There's something happened that created all this stuff. This is not an accident. This is not just bumping molecules and it ended up with this. Absolutely not. Anybody can believe that and push that on people. I can't understand that mentality whatsoever. I can't understand that lack of mentality. All right, so anyway, I guess I'll leave it at that for today. I love you all. All right, this is this is an hour long, so I'm going to go cut to the chase here. We base all our clinical assessments on trial, mostly lab rats, mice, and they are now genetically totally different than the standard mouse that lives in the woods. They have these excessively long telomeres, which a telomere is every time something goes wrong in your body, it breaks off a little piece of this telomere and then you die. Now, the lab rats can live forever, but they get cancer. But they're still able to to continue to live, is what this guy is saying. And they did find out that lab mice, when they were just given water and it didn't have anything it couldn't produce any enzymes and so forth in the gut, they died very quickly. Well, they died young. And then if they gave them olive oil and they gave them this another chemical, I think it's AIP or something like that, they lived twice as long. So, but the key here is its rejection of science. To me, I think that's what he's going to end up saying.
Use those animals in order to test a new drug, to see whether it would be safe to give them to people. You get a paradoxical effect, or at least the hypothesis suggests that the effect should be that the damage that is done to those mice by these drugs, unless it is so extreme in the moment that it kills them outright, will not be harmful to them, because mice, unlike us, can replace their tissues indefinitely.
So basically what he's saying, they give these mice drugs, it doesn't matter. They're not going to die from them.
In fact, because these mice seem to all get cancer if you let them live long enough, a poisonous drug may actually extend their lives because it functions as a kind of chemotherapy. So the not-so-funny joke told in chemotherapy wards is that the whole purpose of chemotherapy is to kill the tumor faster than you kill the patient, right? Tumors are more vulnerable than regular tissues because their DNA is constantly dividing, and when DNA is dividing, it is vulnerable in a way that DNA that is paired is not. And so these mice are suffering from an unusual cancer load, and a poisonous drug that actually damages cells that are vulnerable will actually interrupt their cancer's ability to grow, and so they may actually live longer than their non-drug counterparts.
Now, if he's right, and I'm not saying he is because I don't know, but if he is right, they're not testing anything. They're not testing them on actual people. And then when the people actually get sick, there's always some other reason. Anyway.
In any case, though, the result of this is that you will administer drugs in high doses to mice to see whether or not they are poisonous. Mice will not respond the way people do because of their unusual telomeres, which have evolved to be long in the laboratory colonies. And then when you release the drug into the human population, these toxins will do damage in our bodies, which will be particularly visible when it affects the heart, because the heart has a low capacity for cellular repair, and when the heart fails, it's very noticeable. So the idea is that something like Vioxx, which turned out to be destructive of heart tissue, was released into the public because our mechanism for testing whether it would be safe in mice had failed us. There are quite a number of other drugs that have shown the same pattern. We thought they were safe. They were then released. They turn out to do heart damage. They're pulled from the market, or warnings are appended to them. So the question is, have we made an error where something about our laboratory environments is creating mice that make drugs look much safer than they actually are, and causing us actually to suffer pharmaceutical harm that is unnecessary?
All right. Again, I'm going to cut in. Our pharmaceuticals, we're trying to fool Mother Nature. I don't think you can do it all that well and that easily. This is something, again, God designed DNA and designed all of the little intricacies that go with it. I'm going to tell you something else that's just hilarious. There's 98% of our DNA. The experts, until just recently, used to say, oh, it's just junk DNA. It's just extra stuff just laying around in there. That's insanity. Absolute, total insanity. That 98% is now they have discovered. There's, is GCAT. Oh boy, I'm telling you, my mind is not going. But anyway, it's the GC codes that do the programming. It's called methylation. And when a certain section in the double helix gets methylated, it goes out to the GC islands. There's a whole 98% of your DNA is all these little codes laying around out there. It says activate this section right here. This turns on, and that is the codes that control you. Now, if this guy has a problem turning on or off, or some other interference happens here, and it doesn't get turned on here, or it gets turned on excessively, or the wrong thing gets turned on, it's supposed to be this, and it's down here because this was glyphosate instead of glycerol, this is what you get. All right, he's talking about this mouse model not working, but nobody cares.
The mind reels. I can't fathom that, given the amount of interest in this story, and this video is just soared up the charts. It's now over 100,000 views. It must be 250,000 downloads, that came very quickly. Many people have heard it. And the interesting thing is how interested everyone is in the story, and how the interest is least in the place that you would expect it most. I would imagine if this was a wrong story, we would be hearing nothing but chortling from the molecular biology community telling us how badly we've understood what in fact is going on. Or I would want to understand from the news media, tell me, why is this uninteresting to you?
It's a bad problem. It's a depressing situation when you can't break through. And that's why I'm taking this opportunity. I know, I never make hours-long videos. This is, I don't know how many hours this is going to go. I don't care. Because now we have time to look into this. I have so many things of such deep interest. Not, some of them are just exciting things, really interesting things. But if you look at them in the deepest meaning that they have, these Kim's head, it's a Naga head, and Tish finds these feet, they're no toes. We got them everywhere. These are things we should be looking into. They relate to our eternity, really. I'm looking at them for just kind of fossil interest. Yes, absolutely, but I'm going much, 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 much deeper, because just like he said, we need to understand death. All right? When you die, you're just going to die and hope for the best? I'm not. And I told you, I don't know if I've said it in this one or not, I saw my mother-in-law meet her husband. I saw it. And I see things people don't see. It started when I saw the Mudfossils, and I started finding thousands of them, tens of thousands of them, and I knew what they were as soon as I looked. And then everything came into view: the dragon, the fish, every single thing that I looked at, I could understand. I'm telling you, I'm not saying I'm a genius or anything, but I could see the depth of it that has been missed, because I must have, the first finding of giants. I mean, what are you going to do after that? And then I got a message that said these things are for you to see and for others as a test. It came right on my screen. I saw my mother-in-law meet her husband, and when she saw him, her face just went into a huh? Like, what? Wow. And my father-in-law had the biggest grin on his face, and I saw this right in front of me at her funeral. And I don't care what anybody says. If you don't believe me, good for you. I saw it with my own two eyes. I see things you do not see. Now it's time to start saying things and get this stuff known. If you want to get out of this alive and get to the other side and meet some of your friends and your family and people that you loved, you all better start figuring a way to make that happen. Because what I'm seeing is nobody paying attention to anything. My own family, I got the same thing. Nobody wants to talk to me anymore. I don't blame them. So what do? You just go about your life and hope for the best. Hello, my friends. You're going to have a wonderful time learning today about lactic acid bacteria to fight against antibiotic-resistant uropathogens. Well, what are we talking about here? We got issues. We got serious issues with the health system. I mean, seriously. And this coronavirus thing just throws another point to the tip of the pencil. Now, here's the abstract. Antibiotic resistance. Okay, we're giving them we're giving them antibiotics, give them broad spectrum kill anything in them, antibiotics. Well, it does, but then you got serious global health issues, not only because they will no longer respond to these drugs, but because these drugs create other issues. They kill the real biotics in your body that are there to help you. Your gut is loaded with microbacteria. There are all kind of bacteria in you, and they create enzymes, they create mucus, they create poop that is the molecular size that we can work with it. And the enzymes are little chemistry sets, and they are designed by God for that bacteria to make a chemical to go attack something that's going to give you Alzheimer's disease, or something that's going to clog your lungs up, or something that's going to go and obstruct your something in your heart. They are there to do good things for you. Now, I don't know exactly which ones or what exactly changed these bacteria and these enzymes, but I'm going to show you, there's obviously evidence that we are changing them to see if we can make better things, but in the meantime, we don't know what we're doing, so we're ending up with like coronavirus. And it appears that that's something that they made. All right? And this is the problem. We're creating these kind of changes. So we're looking at lactobacillus, and I'm telling you, we've had success with autism, and this stuff is loaded with it. 1, 2, 3, 4, 5, 6, 7 different strains of lactobacillus in there, and that's what we've been given to autistic kids, and it's been making them come around, and I mean quite significantly. And a couple other little things, but mostly just the prebiotic, probiotics. And I got to be honest with you, it's the one lady that we've been working with has had just phenomenal success. She's very happy. She's been going quite a bit over the dose of what it recommends, but I don't think there's a downside to going over the. Because these don't grow inside you. I don't think you need something that's going to attach to the membranes, the cellular membranes and all that stuff, so that it's right there and can attack, as it's being invaded. We're getting invaded, and then we're going over to try to stop it, and it's successful, but there's a vulnerability there because it's not attacking back at the stuff. In other words, you gotta embed these bacteria. They live there. They love it. They live inside the membranes, and these membranes have thousands of layers, and these have thousands of bacteria that live, and they're all kind of different bacteria, maybe all the same in places, but they do a job of breaking down the stuff that comes past them, the food and all that stuff. This is what they do. They eat it, and when they do, they create products. That is their job in life, programmed by God to do that. And now we have changed the programs that they're running on. So they're not dealing with the products that they were designed to deal with. They have other products now that they never anticipated. Or they are also redesigned themselves now so that they're not able to deal with the products they should have been able to deal with. We're too far away from the organic model. Too far away. The glyphosate is an absolute disaster. And that is the worst chemical. And they spray it right onto the food just before they harvest it. All the stuff they tell you that's good to eat, all your bran and your cereals and all your oats and all that stuff, just before they harvest it, they go out and they slaughter it with glyphosate, which is one of the worst chemicals that man has ever designed. It mimics the gly chemicals in your body, which are the tiniest little protein creators. They are what they call the progenitors of proteins, little bits and pieces that make proteins. So if they're bad, which they are, you got wrong proteins. The proteins are not going to come out right. And it's because the glyphosate is substituting for these glycine or glycerol or whatever it is. I can't remember the names, but there's all kinds of names. The GLY is, I think it's glycine, yeah, is the basic molecule that makes amino acids and proteins. And those are the things that are the programs that create the things for your body to go out and fix the things that are broken in your body. I'm not kidding you. It's really that simple and that complex. These bacteria were designed to create enzymes, which are chemistry sets, not alive. They go out and they speed up reactions and they break molecules and get them ready to reconnect to make new molecules. They clean up molecules, they break them up so small, they can go out in the feces or the urine or wherever. They get out in the body, blow out through your lungs, carbon dioxide, carboxylation. All this stuff happens by little attachments in your body as things flow through. And if you don't have the things to attach, you're screwed. If you don't have the things flowing through that those things can attach to, screwed a second time. And if the things that are flowing through are re-engineered by some scientist to not do the thing that God made them do, screwed times 3. I don't know what else to say. You know, you would think our scientists would, some of them would get a collaboration of them coming together and saying, we got to stop this. This is ridiculous. What are we letting these people do? What are we letting it happen in our world? What are we responsible for? What have we brought on society? What have they asked us to do, and what have we delivered? All right? I mean, I don't want to be nasty to people. I don't want to be ugly, but I'm telling you, nobody cares that I can find enough to stand up, because they're going to be beaten down. I'm sort of, see, I can say these things because I don't have to, nobody's employing me. I don't have to go collect a paycheck, and I don't care that much about what people think of me. I really don't. I know what they think of me now, so if I cared, I wouldn't be saying what I'm saying. So, for me, it's a wide open stage. And I am going to scream on this stage until I see something change. And either that or I stop breathing oxygen. It's one or the other.